Okay, so I've got 3 examples up on the board, okay? We're going to give you guys some time to do each one of these examples. So whoever's manning this film right now in class, you're going to pause after I describe each problem, and then you're going to let the students work on it for maybe 4 or 5 minutes, and then we are going to go through it as a class, okay? So it's like I'm right here. It's like I never left, okay? Cool. First problem, we have a 10 kilogram mass. That 10 kilogram mass is moving to the right with an acceleration of 5 meters per second squared. And I want you guys to find the force that's being applied to this mass. Remember, this mass has an acceleration, so its motion is changing. It's speeding up. So that must mean that there is some force acting on it. We're trying to figure out what that force is, okay? This is the part where you pause. Ready? Okay, so mass is 10 kilograms. The acceleration is 5 meters per second squared. Let's go to Newton's second law. This is the one you're going to use all the time. Force is equal to mass times acceleration. Okay? We know the mass of the object. We know the acceleration of the object. We should be able to find the force that's acting on it. Force is equal to, the mass is 10 kilograms. Again, we're not too worried about units this summer. We're just focused in on physics. 10 kilograms multiplied by the acceleration, which is 5, we get a force of 50 newtons. So that means that the force being applied to this box is 50 newtons. Okay? You are pushing it with 50 newtons of force. That's the total force acting on it. There are still other forces acting on this block right now. There's the force of gravity trying to pull it down. There's the force from the floor acting up. However, those two forces are balanced. The block isn't falling through the floor and it's not levitating. That'd be weird. It's moving to the right with some acceleration. That's what we're focused on right now. This total force will also be referred to as a net force, N-E-T. The total force will sometimes be referred to as a net force. Okay? Next problem. Mass of 5 kilograms, a force of 75 newtons is being applied to it. I want you guys to find the acceleration. This is another opportunity for the person manning the video to hit the pause button. Ready? Okay. Once again, force is equal to mass times acceleration. In this instance, I have the force. I'm trying to find the acceleration. F equals ma. The force is 75 newtons. That's equal to the mass of 5 kilograms multiplied by the acceleration. The acceleration is 15 meters per second squared. Okay? So we are applying a force to this block. It's like I'm pushing the block the whole time with the same force, 75 newtons. That constant force being applied to the block is going to move it to the right and it's going to accelerate. And the acceleration is 15 meters per second squared. Okay? Now, the next one, a little bit more complicated. We have a mass of 15 kilograms, only now we have two forces acting on it. We have a 75 Newton force to the right and a 15 Newton force to the left. And we want to find the acceleration on this guy. Once again, person manning the video, go ahead and pause, and then we will talk about this problem. I thought about just standing here like perfectly still when the person hits the play button, and then they're not sure if they hit the play button, but then I just figured I'd be messing with people. So I'm not going to do that. Okay, so one force to the right, 75. One force to the left, 15. We're going to subtract those two forces. This is like I'm pushing from the right-hand side of the block. Your friend is pushing from the left-hand side of the block. You're not pushing together. You're trying to oppose each other's motion. So it's going to be the total force, F total, is equal to F1 minus F2. F1 minus F2. So the 75 Newton force is trying to take us to the right. The 15 Newton force is trying to take us to the left. Last time I checked, 75 was bigger than 15. So this thing is going to accelerate to the right. The total force is equal to 75 minus 15. So that's equal to 60 newtons. That was a weird 6. Let me erase that and try that again. 60 newtons. So we've got 60 newtons of force right now. That's going to be equal to mass times acceleration, Newton's second law. F equals ma. So 60 newtons is equal to the mass of the object, which is 15, multiplied by the acceleration. 60 divided by 15, we get an acceleration of 4 meters per second squared. Now, if this was just the 75 newtons, so let's imagine that the 15 wasn't there. If that was just 75 newtons, then it would be 75 divided by 15, which would not give you 4, that would give you 5 meters per second squared, right? So in this case, because your friend was pushing in the opposite direction, this object is not going to accelerate as fast as you wanted it to, okay? Your friend is hurting you in this problem, they're not helping you. Keep that in mind on tonight's homework assignment, okay? So we talked about Newton's 3 laws, we talked about balanced and unbalanced forces, and then we gave some examples, okay? You guys should have a homework assignment for tonight. When I come back, we're going to go over the test on Monday, and then Tuesday we're going to go over new material. And that new material is going to include friction, which always opposes your motion. So we're going to talk about how to calculate friction and how it always opposes your motion. You may now stop the video, hand out the homework, and let them work for a little bit.